Question 14b. The derivative of a function y equals f of x is given by f dash of x is equal to 3x squared plus 2x minus 1. Part 1. Find the x values of the two stationary points of y equals f of x and determine the nature of the stationary points. The following are the marking guidelines for question 14b, part 1. For 1 mark, we have finds both x values and determines the nature of one stationary point or equivalent merit. And for 2 marks, we have provides correct solution. Find the stationary points by solving f dash of x equals 0. Now f dash of x represents the first derivative, and in this case it's 3x squared plus 2x minus 1. So we're going to solve the equation 3x squared plus 2x minus 1 equals 0. And this happens to be a non-monic quadratic trinomial. So using the quadratic formula, we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 1 over 2 times 3. And simplifying the right hand side, we get x equals negative 2 plus or minus the square root of 16 over 6. And the square root of 16 is equal to 4. And therefore, x equals negative 1 or 1 over 3. To determine the nature of the stationary points, we can use the second derivative, f double dash of x is equal to 6x plus 2. And we get that by differentiating the first derivative. So f double dash of negative 1 is equal to 6 times negative 1 plus 2, which equals negative 4, which is less than 0. Hence, x equals negative 1 is a local maximum point. And f double dash of 1 over 3 is equal to 6 times 1 over 3 plus 2, which is equal to 4, which is greater than 0. Hence, x equals 1 over 3 is a local minimum point. Part 2. The curve passes through the point 0, 4. Find an expression for f of x. The following are the marking guidelines for question 14b, part 2. For 1 mark, we have finds correct primitive or equivalent merit. And for 2 marks, we have provides correct solution. F of x is the primitive of f dash of x. Hence, f of x is equal to the integral of f dash of x dx. And f dash of x is equal to 3x squared plus 2x minus 1. Therefore, f of x is equal to the integral of 3x squared plus 2x minus 1 dx. And this equals x cubed plus x squared minus x plus the constant of integration c. Now we know that the curve y equals f of x passes through the point 0, 4. And we can use that information to find the value of the constant of integration c. So when x equals 0, y equals 4, and substituting this information into f of x equals x cubed plus x squared minus x plus c, we have 4 is equal to 0 plus 0 minus 0 plus c, hence c equals 4. Therefore, f of x is equal to x cubed plus x squared minus x plus 4. Part 3. Hence sketch the curve, clearly indicating the stationary points. The following are the marking guidelines for question 14b, part 3. For 1 mark, we have provides curve with correct shape or equivalent merit. And for 2 marks, we have provides correct sketch. The first step is to find the location of the stationary points found in part 1. And we can use the function we found in part 2 to find the y-coordinate of the stationary points found in part 1. So f of negative 1 is equal to negative 1 cubed plus negative 1 squared minus negative 1 plus 4, taking care to enclose these values in brackets, and that equals 5. And f of 1 over 3 is equal to 1 over 3 cubed plus 1 over 3 squared minus 1 over 3 plus 4, and that equals 103 over 27, or 3n 22 over 27. Now f of x is a polynomial of degree 3. It's cubic, with a positive leading term, x cubed, and a y-intercept at 0, 4. And that gives us an idea of what shape the curve will take. So putting that all together, this point here, negative 1, 5, represents the local maximum stationary point. This point here, which is 1 over 3, 103 over 27, represents our local minimum stationary point. And this point here represents the y-intercept. Part 4. For what values of x is the curve concave down? The curve is concave down where the second derivative f double dash of x is less than 0, and f double dash of x is equal to 6x plus 2. So we're going to solve the inequality 6x plus 2 less than 0. Subtracting 2 from both sides of the inequality, we get 6x is less than negative 2. Then dividing both sides of the inequality by 6, we get x is less than negative 1 over 3. Hence the curve is concave down for values of x less than negative 1 over 3. The following is the feedback from the Marking Centre for question 14b. Students should factorise a non-monic trinomial to obtain solutions to equation. Show numerical results when testing stationary points using either the first or second derivative. Use a table with labelled rows indicating x, dy dx and slope when using the first derivative test. Integrate and substitute in 0, 4 to calculate the constant. Provide information about the nature of the stationary points, and find and show the coordinates of the stationary points. In better responses, students were able to factorise a non-monic trinomial, show values in their tests for nature of stationary points, correctly calculate the constant, calculate the y-coordinate at x equals negative 1 in y equals x cubed plus x squared minus x plus 4, match their information from B part 1 to their graph in B part 3, and understand that when f double dash of x or the second derivative equals 0, a curve is not concave down. Areas for students to improve include using f dash of x equals 0 to find stationary points, understanding the link between the sign of the second derivative and concavity, understanding what a local maximum stationary point looks like graphically, understanding that f double dash of x less than 0 for concave down, solving linear inequalities accurately, and checking that all parts of a question are attempted.